An equinox is an astronomical event in which the imaginary plane of Earth's equator passes the center of the Sun, making night and day of approximately equal length all over the planet. The equinoxes are the only times when the solar terminator is perpendicular to the equator. As a result, the northern and southern hemispheres are equally illuminated. In other words, the equinoxes are the only times when the subsolar point is on the equator, meaning that the Sun is exactly overhead at a point on the equatorial line. Equinoxes occur twice a year, around the 21st of March and the 23rd of September. The subsolar point crosses the equator moving northward at the March equinox and southward at the September equinox. The equinoxes, along with solstices, are directly related to the seasons of the year. In the northern hemisphere, the vernal equinox conventionally marks the beginning of spring in most cultures, and the autumnal equinox marks the beginning of autumn. In the southern hemisphere, the vernal equinox occurs in September and the autumnal equinox in March. Terminology. The oldest meaning of the word equinox is the day when daytime and night are of approximately equal duration. The word equinox comes from this definition, derived from the Latin equinoctium, equus and nox. The equinox is not exactly the same as the day when period of daytime and night are of equal length for two reasons. First, sunrise, which begins daytime, occurs when the top of the Sun's disk rises above the eastern horizon. At that instant, the disk's center is still below the horizon. Second, Earth's atmosphere refracts sunlight. As a result, an observer sees daylight before the Sun's disk rises above the horizon geometrically. To avoid this ambiguity, the word equinox is sometimes used to mean a day on which the periods of daylight and night are equal. Times of sunset and sunrise vary with an observer's location, so the dates when day and night are closest together in length depend on location. Equinoxes on the Earth. Illumination of Earth by the Sun. The March equinox. The Earth in its orbit around the Sun causes the Sun to appear on the celestial sphere moving over the ecliptic, which is tilted on the equator. Diagram of the Earth's seasons as seen from the north. Far right. December solstice. Diagram of the Earth's seasons as seen from the south. Far left. June solstice. Date when Julius Caesar established his calendar in 45 BC. He set the 25th of March as the spring equinox. Because a Julian year is slightly longer than the tropical year, the calendar drifted with respect to the equinox, such that the equinox was occurring on about the 21st of March in AD 300 and by AD 1500 it had reached the 11th of March. This drift induced Pope Gregory XIII to create a modern Gregorian calendar. The Pope wanted to continue to conform with the edicts concerning the date of Easter of the Council of Nicaea of AD 325, which means he wanted to move the vernal equinox to the 21st of March, which is the day allocated to it in the Easter table of the Julian calendar. However, the leap year intervals in his calendar were not smooth. This causes the equinox to oscillate by about 53 hours around its mean position. This in turn raised the possibility that it could fall on the 22nd of March, and thus Easter Day might theoretically commence before the equinox. The astronomers chose the appropriate number of days to omit so that the equinox would swing from 19 to the 21st of March but never fall on the 22nd. Names: spring equinox and fall equinox. Colloquial names based on the seasons. However, these can be ambiguous since the northern hemisphere's spring is the southern hemisphere's fall, and vice versa. The Latinate names vernal equinox and autumnal equinox are often used to the same effect. March equinox and September equinox. Names referring to the months of the year they occur, with no ambiguity as to which hemisphere is the context. They are still not universal, however, as not all cultures use a solar-based calendar where the equinoxes occur every year in the same month. Northward equinox and southward equinox. Names referring to the apparent direction of motion of the Sun. The northward equinox occurs in March when the Sun crosses the equator from south to north, and the southward equinox occurs in September when the Sun crosses the equator from north to south. These terms can be used unambiguously for other planets. First point of Aries and first point of Libra, names referring to the astrological signs the Sun is entering. Due to the precession of the equinoxes, however, the constellations where the equinoxes are currently located are Pisces and Virgo, respectively. Length of equinoctial day and night on the day of the equinox. The center of the Sun spends a roughly equal amount of time above and below the horizon at every location on the Earth, so night and day are about the same length. The word equinox derives from the Latin words equus and nox. In reality, the day is longer than the night at an equinox. Day is usually defined as the period when sunlight reaches the ground in the absence of local obstacles. From the Earth, the Sun appears as a disk rather than a point of light, so when the center of the Sun is below the horizon, its upper edge is visible. Furthermore, the atmosphere refracts light, so even when the upper limb of the Sun is 0.4 degrees below the horizon, its rays curve over the horizon to the ground. In sunrise-sunset tables, the assumed semi-diameter of the Sun is 16 minutes of arc and the atmospheric refraction is assumed to be 34 minutes of arc. Their combination means that when the upper limb of Sun is on the visible horizon, its center is 50 minutes of arc below the geometric horizon, which is the intersection with the celestial sphere of the horizontal plane through the eye of the observer. These effects make the day about 14 minutes longer than the night at the equator and longer still towards the poles. The real equality of day and night only happens in places far enough from the equator to have a seasonal difference in day length of at least 7 minutes, actually occurring a few days towards the winter side of each equinox. Because the Sun is a spherical source of light, the actual crossing of the Sun over the equator takes approximately 33 hours. At the equinoxes, the rate of change for the length of daylight and nighttime is the greatest. At the poles, the equinox marks the start of the transition from 24 hours of nighttime to 24 hours of daylight. Far north of the Arctic Circle, at Longyearbyen, Svalbard, Norway, there is an additional 15 minutes more daylight every day about the time of the spring equinox, whereas in Singapore, the amount of daylight in each daytime varies by just a few seconds. Geocentric view of the astronomical seasons in the half-year centered on the June solstice. The Sun rises north of east and sets north of west, which means longer days with shorter nights for the northern hemisphere and shorter days with longer nights for the southern hemisphere. In the half-year centered on the December solstice, the Sun rises south of east and sets south of west, and the durations of day and night are reversed. Also on the day of an equinox, the Sun rises everywhere on Earth at about 600 and sets at about 1800. These times are not exact for several reasons. The Sun is much larger in diameter than the Earth, so that more than half of the Earth could be in sunlight at any one time. Most places on Earth use a time zone which differs from the local solar time by minutes or even hours. For example, if the Sun rises at 700 on the equinox, it will set 12 hours later at 1900. Even people whose time zone is equal to local solar time will not see sunrise and sunset at 600 and 1800. This is due to the variable speed and the inclination of the Earth's orbit, and is described as the equation of time. It has different values for the March and September equinoxes. Sunrise and sunset are commonly defined for the upper limb of the solar disk, rather than its center. The upper limb is already up for at least a minute before the center appears, and the upper limb likewise sets later than the center of the solar disk. Also, when the Sun is near the horizon, atmospheric refraction shifts its apparent position above its true position by a little more than its own diameter. This makes sunrise more than 2 minutes earlier and sunset an equal amount later. These two effects combine to make the equinox day 12h7 min long and the night only 11h53 min. Note, however, that these numbers are only true for the tropics. For moderate latitudes, the discrepancy increases, and closer to the poles it becomes very much larger. Up to about 100 kilometers from either pole, the sun is up for a full 24 hours on an equinox day. Night includes twilight. If dawn and dusk are instead considered daytime, the day would be almost 13 hours near the equator, and longer at higher latitudes. Height of the horizon changes the day's length. For an observer atop a mountain, the day is longer, while standing in a valley will shorten the day. Day arcs of the sun. Some of the statements above can be made clearer by picturing the day arc. The pictures show this for every hour on equinox day. In addition, some ghost suns are also indicated below the horizon, up to 18 degrees below it. The sun in such areas still causes twilight. The depictions presented below can be used for both the northern hemisphere and the southern hemisphere. The observer is understood to be sitting near the tree on the island depicted in the middle of the ocean. The green arrows give cardinal directions. In the northern hemisphere, north is to the left. The sun rises in the east, culminates in the south, while moving to the right and setting in the west. In the southern hemisphere, south is to the left. The sun rises in the east, culminates in the north, while moving to the left and setting in the west. The following special cases are depicted. Day arc at 0 degrees latitude. The arc passes through the zenith, resulting in almost no shadows at high noon. Day arc at 20 degrees latitude. The sun culminates at 70 degrees altitude, and its path at sunrise and sunset occurs at a steep 70 degrees angle to the horizon. Twilight still lasts about 1 hour. Day arc at 50 degrees latitude. Twilight lasts almost 2 hours. Day arc at 70 degrees latitude. The sun culminates at no more than 20 degrees altitude, and its daily path at sunrise and sunset is at a shallow 20 degrees angle to the horizon. Twilight lasts for more than 4 hours. In fact, there is barely any night. Day arc at 90 degrees latitude. If it were not for atmospheric refraction, the sun would be on the horizon all the time. Celestial coordinate systems. The vernal equinox occurs in March, about when the sun crosses the celestial equator south to north. The term vernal point is used for the time of this occurrence and for the direction in space where the sun is seen at that time, which is the origin of some celestial coordinate systems. In the ecliptic coordinate system, the vernal point is the origin of the ecliptic longitude. In the equatorial coordinate system, the vernal point is the origin of the right ascension. Strictly speaking, at the equinox the sun's ecliptic longitude is 0. Its latitude will not be exactly 0 since the Earth is not exactly in the plane of the ecliptic. Its declination will not be exactly 0 either. The modern definition of equinox is the instance when the sun's apparent geocentric longitude is 0 degrees or 180 degrees. See the diagram to the right. Because of the precession of the Earth's axis, the position of the vernal point on the celestial sphere changes over time, and the equatorial and the ecliptic coordinate systems change accordingly. Thus, when specifying celestial coordinates for an object, one has to specify at what time the vernal point and the celestial equator are taken. That reference time is called the equinox of date. The autumnal equinox is at ecliptic longitude 180 degrees and at right ascension 12h. The upper culmination of the vernal point is considered the start of the sidereal day for the observer. The hour angle of the vernal point is, by definition, the observer's sidereal time. The same is true in Western tropical astrology. The vernal equinox is the first point of the sign of Aries. In this system, it is of no significance that the equinoxes shift over time with respect to the fixed stars. Using the current official IAU constellation boundaries, and taking into account the variable precession speed and the rotation of the ecliptic, the equinoxes shift through the constellations as follows. The March equinox passed from Taurus into Aries in year 1865, passed into Pisces in year 67, will pass into Aquarius in year 2597, will pass into Capricornus in year 4312. It passed along a corner of Cetus on 0 degrees 10 distance in year 1489. The September equinox passed from Libra into Virgo in year 729, will pass into Leo in year 2439. Cultural aspects: a number of traditional spring and autumn festivals are celebrated on the date of the equinoxes. Equinoxes of other planets. Equinox is a phenomenon that can occur on any planet with a significant tilt to its rotational axis. Most dramatic of these is Saturn, where the equinox places its ring system edge-on facing the Sun. As a result, they are visible only as a thin line when seen from Earth. When seen from above, a view seen by humans during an equinox for the first time from the Cassini space probe in 2009, they receive very little sunshine. Indeed, more planets shine than light from the Sun. This lack of sunshine occurs once every 14.7 years. It can last a few weeks before and after the exact equinox. The most recent exact equinox for Saturn was on the 11th of August 2009. Its next equinox will take place on the 30th of April 2024. One effect of equinoctial periods is the temporary disruption of communications satellites. For all geostationary satellites, there are a few days around the equinox when the Sun goes directly behind the satellite relative to Earth for a short period each day. The Sun's immense power and broad radiation spectrum overload the Earth station's reception circuits with noise and, depending on antenna size and other factors, temporarily disrupt or degrade the circuit. The duration of those effects varies but can range from a few minutes to an hour.